Now that we have what an identity is, let me just really quickly run down a list of things that we're going to be doing with them throughout our course. And really, for you guys in engineering and sciences, you're going to be doing this forever and ever. The first one begins with we're going to be able to find values for trig functions. Now, this is something we've actually done, so this might actually feel a little bit like review. Okay, so this is something we've done before. Solving equations with trig functions. This is something that'll come up later. All right, but as you saw with that introduction video, we used identities before to solve polynomial equations. So of course we're going to use them to solve trigonometric equations. So that'll come up. We're going to simplify or rewrite expressions with trig functions. Again, I think this is something that's a little bit of review, but we're going to see a lot of this. This is probably going to be very important because it also helps us verify identities. So verifying identities is 5.2. Solving equations will come up later in Chapter 5 and definitely in Chapter 6. And then finding trig values is something that we've already done before, right? And then and simplifying and rewriting expressions of trig functions, we'll start doing that right now pretty quickly. Okay, so those are the big things that we do with identities. And so let's get rolling. So let's do the review. Let's find some values. So how do I find the secant of 210 degrees? Right, we'll go back into degree mode. Well, we'll begin by using our reciprocal identity, right? So secant is 1 over cosine. And then once we have that, 210 is actually one of our nice reference angles, or one of our nice angles. We'll just go to the unit circle, if you would. And for 210 degrees, right, we're in quad 3. That's for starters. And for that one, for 210 degrees, cosine is negative square root of 3 over 2. All right, that's our x-coordinate. So this basically becomes negative 2 square roots of 3. Rationalizing our denominator, we get negative 2 square roots of 3 over 3 as our value for the secant of 210 degrees. So again, the identity was used here at this location, and then since we had a nice unit circle value, I used that to find the exact value. Tangent to 2 pi over 3, well, again, using a quotient identity, this is the sine of 2 pi over 3 divided by the cosine of 2 pi over 3. And again, 2 pi over 3 is another nice unit circle. This is occurring in quad number 2. And so for cosine of 2 pi over 3, our sine value is square roots of 3 over 2, and our cosine value is negative 1/2. So multiplying by the reciprocal, the 2's cancel out. Positive times a negative is a negative, so we end up with the negative square roots of 3 as our final answer for the tangent of 2 pi over 3. All right, so again, we're just using the trig identity, right? In this case, the quotient rule, and then the unit circle and our quadrant understanding from the past. So we've done this before. We're just kind of reiterating it, maybe doing some good review. What about the sine of negative 45? Well, this is in quad number 4, right? And so we really don't need an identity for this. However, we have a negative, so how about we use the odd identity? This would be the same as the sine of 45 degrees. So this is the negative square roots of 2 over 2. So that would be our final answer there. Of course, we could have just done that by considering we're in quad 4, and down in that quadrant, 45 degrees, right, gives us negative square roots of 2 over 2 as well. But what I use is the odd, right? The sine of a negative is the negative of that sine of 45, all right? And so the negative of square root of 2 over 2, no matter how you cut it, we get that. So perhaps the odd identity was redundant, but we did use that. Same thing here for cosine. We know that this is basically negative rotation, and we're in quad 3, so we could use that, or we can use the even identity that says the cosine of a negative is the same as the cosine of its positive. And of course, this now puts us in quad 2, and what we get is negative square roots of 3 over 2, referring to my unit circle at this time. Okay, so here I had an opportunity to use the odd identity. Here I use the even identity. and then I just used my unit circle to find our exact values. Okay, and on we can continue to do this. So find the trig function values. If we know that the cosecant of theta is 2.35, find the value of the cosecant of negative theta. Well, using the odd identity, this is equal to the negative of cosecant of theta. Of course, they already told us what cosecant of theta is. It's 2.35. So using our odd identity, we get a negative 2.35 as our answer with regard to that one. Okay, the next one, we're given the cotangent value as 5/2, and we're given that the sine of theta is negative 2 over the square root of 29, and then they're asking us basically to find the cosine of theta. So our theta is in quad number 3, right? That would actually, tangent is positive, sine's negative, so those two alone told us they were in quad 3. How do I find the cosine of theta? Now remember, what we're doing is using trig identities. I know you guys could probably just find, hey, here's here's x, here's y, and there's r. Why don't I just use x, y, r's? And that is a very fast way to do this. However, we're using trig identities. So the trig identity that comes to mind here is we know that the cotangent, let me write this right. The cotangent of theta is the cosine of theta all over the sine theta. All right, so that's cotangent. If we multiply both sides by sine theta, we get that the cosine of theta is sine theta times the cotangent of theta. And this kind of manipulation, notice I took a known quotient identity and I solved it for another one of the variables. So that's a pretty important skill here. But moving right along, what we end up having here, right, we know that the sine of theta is negative 2 square roots of 29, and we know that the cotangent of theta is 5 over 2. So my 2's cancel out, and using my identities, we find that the cosine is negative 5 square roots of 29. Of course, if you guys would have used x, y's, and r's, we'd have gotten the same thing. But there's what that would look like using a trig identity. Okay. So next one, find the sine of theta, given that the cosine of negative theta is 1/3 and tangent is less than 0. Well, what we know, right, when tangent's less than 0, this puts us in quad number 2 or quad number 3. All right, and so cosine of negative theta is 1/3. Well, using my even identity, this means that the cosine of theta is 1/3. So my cosine's positive, right? That's quad 4. All right, and we know that cosine's positive and tangent's negative, right, in quad number 4. All right, so this is quad 1 and quad 4. So we're looking for quad 4. So what do we know about the sine? That it's negative over there. All right, so sine of theta is negative in quad number 4. Now we can do some work. All right, again, I know we have our x, y, r definitions, but we're being asked to use our trig identities. So what relates sine to cosine? The good old-fashioned cosine squared theta plus sine squared theta is equal to 1. Substitute what we know about cosine. We get 1/3 squared plus the sine of squared theta equals 1. This is 1/9 plus the sine of squared theta is equal to 1. If we subtract 1/9 from both sides, we get that the sine squared theta is 1 minus 1/9. All right, this is 9 over 9, so we get that the sine squared theta is 8 over 9. Taking a square root, be careful here, right, because there's two possible answers. There's the sine of theta is plus or minus the square root of 8 all over 3. Of course, 8, the square root of 8, that's 4 times 2, so that's 2 square roots of 2. And so what we end up getting is that the sine of theta is plus or minus 2 square roots of 2 all over my 3. And of course, since we already had done some work, we know that the sine is negative, then the one we want is the negative one. Negative 2 square roots of 2 all over 3. I agree, the XYR definitions are probably so much faster, all right? But we are learning how to use our trig identities, solve them, manipulate them, all right? So make sure you're using trig identities here, all right? I'll allow you to go back to XYR definitions later in this chapter, all right? And how about this? It looks like I'm going to have to find the other trig values given one of them. So this problem's a little bit lengthier than the others, and I already see that I'm 10 minutes into this. So how about I pause and I'll do this last one in its own video and go from there. See you guys in the next video.